2003 International Building Code, or IC, Section 410.10 requires a minimum distance of 50 feet from any occupied building or other structure to the nearest point of a Class 1, Division 2 hazardous classified location. The 2003 National Electrical Code, or NEC, Article 501 covers transformers and transformer vaults. However, it does not specifically address the proximity of transformers to Class 1, Division 2 hazardous locations. NFPA 80A Chapter 50 provides guidelines for the storage and handling of flammable and combustible liquids. Section 50.110 states that transformers or capacitors shall not be located in a Class 1 location unless they are provided with a means to prevent the accumulation of flammable liquids around them. Section 50.111 requires that transformers shall be protected from damage by accidental contact with flammable liquids. NFPA 70, Section 130.16 states that where transformers are located in or adjacent to hazardous classified locations, they shall be installed so as to minimize the risk of fire or explosion. Generally, it is advisable to maintain a safe distance between utility transformers and Class 1, Division 2 hazardous locations. The distance may vary depending on the size and type of transformer, the specific hazardous materials being stored, and the local fire code requirements. It is recommended to consult with the local fire authority for specific guidance. Since the 2003 IBC does not specifically address transformer proximity, you should consult with the local fire authority to determine the minimum safe distance for the transformer from the Class 1, Division 2 chemical storage building. They can provide guidance based on the specific circumstances and local regulations. When considering the placement of a utility transformer near a Class 1, Division 2 chemical storage building, several critical factors must be taken into account to ensure safety and compliance with relevant codes and standards. These considerations extend beyond the specific requirements outlined in the IBC, NEC, and NFPA documents, encompassing a broader understanding of risk assessment and mitigation strategies. Firstly, the classification of the hazardous location itself needs careful evaluation. Class 1, Division 2 locations are defined as areas where flammable gases, vapors, or liquids may be present but are typically contained within closed containers or systems. However, the possibility of accidental release or escape of these substances necessitates stringent safety measures. The extent and duration of potential exposure are key factors in determining the appropriate safety protocols. Secondly, the design and construction of the transformer and its associated equipment play a crucial role. Transformers intended for use in or near hazardous locations should be designed to minimize the risk of ignition. This includes features such as sealed enclosures, pressure relief devices, and temperature monitoring systems. The use of explosion-proof or intrinsically safe components can further enhance safety by preventing sparks or other ignition sources. Thirdly, ventilation is an important consideration, particularly in enclosed or confined spaces. Adequate ventilation can help to dissipate any flammable vapors or gases that may be present, reducing the risk of accumulation to explosive concentrations. The design of the ventilation system should take into account the prevailing wind direction, the potential sources of release, and the physical layout of the area. Fourthly, the potential for accidental spills or leaks of flammable liquids must be addressed. Containment measures, such as dikes or berms, can prevent the spread of spills and protect the transformer from direct contact with flammable substances. The materials used for construction of these containment structures should be compatible with the chemicals being stored and resistant to corrosion or degradation. Fifthly, fire suppression systems are essential for mitigating the consequences of a fire involving the transformer or the stored chemicals. These systems may include automatic sprinklers, foam suppression systems, or manual firefighting equipment. The type and capacity of the fire suppression system should be appropriate for the specific hazards present and comply with local fire code requirements. Sixthly, regular inspection and maintenance programs are necessary to ensure the continued safe operation of the transformer and its associated equipment. These programs should include periodic visual inspections, electrical testing, and maintenance of mechanical components. Any defects or deficiencies should be promptly corrected to prevent potential hazards. Seventhly, emergency response planning is crucial for handling incidents such as fires, explosions, or chemical releases. The emergency response plan should outline procedures for notifying emergency services, evacuating personnel, and containing the incident. Training should be provided to all employees in the proper procedures for responding to emergencies. Eighthly, local regulations and permitting requirements must be carefully followed. Many jurisdictions have specific regulations governing the storage and handling of hazardous materials and the installation of electrical equipment in hazardous locations. Obtaining the necessary permits and approvals is essential for ensuring compliance with these regulations. Ninthly, the size and capacity of the transformer should be carefully considered in relation to the electrical load requirements of the facility. Overloading the transformer can lead to overheating and potential failure, increasing the risk of fire or explosion. The transformer should be sized to accommodate the maximum expected load, with a safety margin to account for future growth. Tenthly, the location of the transformer should be chosen to minimize the potential for damage from external sources, such as vehicular traffic, falling objects, or weather events. Physical barriers, such as bollards or fences, can protect the transformer from accidental impacts. The transformer should also be located away from areas prone to flooding or other natural disasters. 11thly, the grounding system for the transformer should be properly designed and installed to minimize the risk of electrical shock or fire. The grounding system should comply with the requirements of the NEC and should be regularly inspected and tested. 12thly, the use of remote monitoring and control systems can enhance safety by providing real-time information on the condition of the transformer and its associated equipment. These systems can alert personnel to potential problems, such as overheating or excessive vibration, allowing for prompt corrective action. 13thly, the selection of appropriate electrical wiring and conduit is critical for ensuring the integrity of the electrical system in a hazardous location. Wiring and conduit should be rated for the specific environment and should be installed in accordance with the NEC. Explosion-proof fittings and enclosures should be used where necessary to prevent the propagation of flames or explosions. 14thly, the use of non-incentive equipment can further reduce the risk of ignition in a Class 1 Division 2 location. Non-incentive equipment is designed to prevent sparks or other ignition sources from occurring under normal operating conditions. 15thly, the implementation of a comprehensive safety management system can help to ensure that all safety precautions are consistently followed. The safety management system should include written procedures, training programs, and regular audits to verify compliance. 16thly, the documentation of all safety-related activities is essential for demonstrating compliance with regulations and for identifying areas for improvement. Documentation should include records of inspections, maintenance, training, and emergency response exercises. 17thly, the use of qualified and experienced personnel is crucial for ensuring the safe installation, operation, and maintenance of electrical equipment in hazardous locations. Personnel should be properly trained and certified in accordance with industry standards. 18thly, the ongoing review and updating of safety procedures is necessary to reflect changes in technology, regulations, and industry best practices. Safety procedures should be reviewed at least annually and updated as needed. 19thly, the consideration of human factors is important in the design of safety systems. Safety systems should be designed to be user-friendly and easy to understand, minimizing the potential for human error. 20thly, the use of redundant safety systems can provide an additional layer of protection in the event of a failure of the primary system. Redundant systems should be independent of each other and should be designed to operate automatically in the event of a primary system failure. Consulting with the local fire authority is crucial because they possess specific knowledge of local codes, ordinances, and environmental conditions that may influence the safe placement of the transformer. They can assess the specific hazards associated with the chemical storage building, taking into account the types and quantities of chemicals stored, the ventilation system, and the fire protection measures in place. The fire authority can also provide guidance on the appropriate type of transformer for the application, as well as any special requirements for installation and maintenance. In addition, the fire authority can help to coordinate emergency response planning, ensuring that firefighters and other emergency responders are aware of the potential hazards and are prepared to respond effectively in the event of a fire or other incident. By working closely with the local fire authority, you can ensure that the transformer is installed and operated in a safe and compliant manner, minimizing the risk of fire, explosion, or other hazards. Furthermore, consider consulting with a qualified electrical engineer experienced in hazardous location design. An engineer can conduct a thorough risk assessment, evaluate the specific conditions at the site, and recommend appropriate safety measures. The engineer can also assist with the preparation of drawings and specifications, ensuring that the installation complies with all applicable codes and standards. Remember that safety is paramount when dealing with hazardous locations and electrical equipment. Taking the time to carefully evaluate the risks and implement appropriate safety measures can help to prevent accidents and protect people and property.